Thanks for joining me in today's lesson. In this first tutorial, we will find limits algebraically. Please put your calculators away because we will not be using calculators today. So we are in section 13.2 in our textbook, and we're talking about more techniques to finding limits, not just plugging it into the calculator and using the t-table. We're going to be looking at some algebraic techniques today. But before we do that, I'd like you to warm up with try one, evaluate each limit. You already have the skills to do A and B. These are just simple direct substitution. So if you could please pause the video and evaluate these limits first and check your answers in about a minute. Thanks for doing that. Like I said, this is simple direct substitution. We simply plug the -1 right here for the x and right here for the x, and we get a -6 as our limit. Same thing here when we plug a -1 into the denominator and plug a -1 in for the x's in the numerator, we get a -3. So those are easy direct substitution. The problem comes in when we have this type of limit, where we're trying to approach -3. Obviously, a -3 cannot plug into the denominator because then we're going to have this equal to be a 0, and that's no good. If this is equal to 0, we can never divide by 0. So if we plug a -3 into the numerator, though, let's see what happens. -3 squared is 9, plus a -3 would make 9 minus 3 is 6, minus another 6. We actually get a 0 also in the numerator. This is what's called an indeterminate, and it's good news. Obviously, we cannot, this is not the value of our limit. This is an indeterminate. We don't know what the value of the limit is. But the good news is, since we got a 0 in the numerator and the denominator, there must be a common factor that's hiding in the numerator and denominator of this fraction. And all we have to do is find that factor and cancel it away. I know that there's a common factor because if I plug a -3 into one function and get 0, and plug -3 into a different function and also get 0, then -3 is a root or a 0 of those two functions, and therefore they have a shared factor. All we need to do is find it. So what I'm going to do is I'm going to first of all write the limit symbol again, because until I can evaluate a limit, the limit symbol is still there, much like a square root symbol. Until you can evaluate a square root symbol, the square root symbol will stay in your problem. So we've got the limit. I know that there's an x plus 3 in the denominator, and in fact that must be the factor that's hiding in the numerator, since it's the only factor in the denominator. So I'm going to factor this numerator. I know that it's x and x. I'm going to guess the 2 and the 3 because it's probably going to be an x plus 3, and then that must be a -2 to make that -6. And that is indeed how you would factor that numerator. Now that I see the common factor, I can cancel it away, and I will have the limit as x approaches -3 of x minus 2 is the only thing that remains, divided by 1, but I don't need that. Now I have an expression that I can plug -3 right into, so I do not need the limit symbol anymore because I can evaluate the limit. Now I introduce my equal sign, -3 minus 2, of course that's equal to -5. And that is my limit. So that's what we're going to be doing today. We're going to be finding the hidden factors and canceling them away so that we can then plug in the limit, the value that we're approaching in the domain. So let's look at our second example. The limit as x approaches 1. Let's first try plugging a 1 into the denominator. We get 1 cubed minus 1 squared plus 1 minus 1. Well, that would be 1 minus 1 plus 1 minus 1. That does equal 0. And lo and behold, when we plug a 1 into the numerator, we also get 1 minus 1, which is 0. We get that indeterminate, which is good news. That means that we have a common factor that we can cancel away. And in fact, this time I know that that common factor must be x minus 1, because that's the only factor I see in the numerator. So it's nice that we know the common factor is going to be x minus 1, but how are we going to find it? I know that since this is a cubic, there are 3 factors. I know one of them is going to be x minus 1, but what are the other 2 going to be? And how am I going to find it? Well, let me show you 2 different ways. I'm going to first show you synthetic division, We've practiced with synthetic division before. I know that since one of the factors is going to be x minus 1, I know that 1 will be a 0 or will be a root, and I'm going to put that 1 divided into these four coefficients, 1, negative 1, 1, and negative 1 again. When I do this synthetic division, I should get a 0 at the end. I drop this first coefficient down past the line, and then I multiply 1 times 1 and add up my terms, and then I go again, multiply 1 times 0 and add up my terms, and then multiply again, 1 times 1 is 1, and add up my terms. This is my remainder, so I know that indeed 1 is a 0, and this is what's left. Since this 1 used to be 1x cubed, this is now 1x squared, plus 0x, which I don't need, plus 1. So this would be the remaining two factors, and they're actually imaginary. So that's fine. So I know, I'll show you another way. So I know now that the limit as x approaches 1, the numerator is x minus 1, the denominator is x minus 1 times x squared plus 1. So I was able to factor that. There's another way, and this doesn't always work with cubes. I've got x cubed minus x squared. Here, let me do this. Let me put or. So this is one technique. Or, so we've got x cubed minus x squared plus x minus 1. There's a factor technique called factor by grouping. I can group the first two terms and pull out a GCF of just those two terms, and that GCF would be x squared, and I'd be left with an x and a minus sign and a 1. And then I can group the second two terms together and pull out a GCF, but there isn't actually a GCF here, so I'll just pull out a 1 and be left with the x minus 1. And since we have a common factor now, an x minus 1 and an x minus 1, I can factor out that common factor of x minus 1, and I'd be left with my x squared plus 1. So that's another neat way to factor. Not every cubic can do that, but this time it can. So those two ways are non-calculator ways of finding the factors of this denominator. And again, now I see that there's a common factor, it's gone. So I'm going to write the limit as x approaches 1 of the numerator is just a 1 now since there's no other factor up there, and the denominator is my x squared plus 1. Again, notice that the limit symbol is in each one of these steps because I have not yet evaluated the limit, and now I'm actually going to. Once I can do my direct substitution, then I can introduce my equal sign, and I'm going to have 1 divided by, what do I have, 1 squared plus 1, which of course is 1/2. And that's my final answer. So let's look at our final example here in this tutorial. We've got the limit as x approaches 0 of this function. Obviously, I cannot plug a 0 into the denominator because if I did, I would get a 0. If I plug a 0 into the numerator, I get the square root of 1, which is 1, minus 1. I also get my 0, so that's good news. Again, there's that common factor that must be hiding somewhere. It's not hiding well in the denominator because I see it. Here it is, it's x. But it definitely is hiding well in the numerator. I have no idea where that factor of x is going to be. You can't factor with square roots, can you? So what are we going to do here? Well, first I'm going to erase this because I'm going to need the space right here. When you're dealing with square roots and you don't really like what it looks like, you can always use conjugate. I'm going to multiply the top and the bottom by the conjugate, the square root of x plus 1 minus 1 with the square root of x plus 1 plus 1. I'm going to multiply top and bottom by the conjugate. Conjugates are helpful to clean up your fractions when they are not in helpful forms, I guess. Conjugate. Some people like to think of it as like an opposite idea. The only thing that's opposite, though, is the middle sign of the binomial. Here it's a minus sign, here it's a plus sign. Nothing else changes. So let's see what happens here. I'm going to FOIL the numerator. Let me write my limit symbol. The limit as x approaches 0. The denominator I'm definitely going to keep in factored form because remember the whole point of doing this is to cancel out a common factor, so there's no reason for me to distribute because this x will cancel away soon. So the first term, square root of x plus 1 times square root of x plus 1. The square roots kind of knock each other out, and we just get x plus 1. The outer terms would be square root of x plus 1 times 1, which is the square root of x plus 1. The inner terms, negative 1 times the square root of x plus 1 becomes a negative square root of x plus 1. That's why inner and outer terms of conjugates, when multiplied, will always cancel away. And my last terms, negative 1 times positive 1, of course, make negative 1. Okay, so these inner and outer terms, bye-bye, we don't need those. This is the limit as x approaches 0. I'm leaving my denominator in factored form still, of course. And let's see what I have in the numerator. I have x plus 1 minus 1. Hey, look at that. The 1's also cancel away. And I'm left with x. I found it. I found that common factor. It was hiding, but I found it. Whew. Cancel it away. And I've got the limit as x approaches 0. I still have not done my substitution. 1 is the only thing in the numerator. Square root of x plus 1 plus 1 is what's left in the denominator. Hopefully now I have a fraction, a function that I can plug a 0 into, and I do. I can plug a 0 right in here for x, so I can introduce my equal sign. 1 is what's in the numerator, and this becomes the square root of 0 plus 1 plus 1. So this is 1 divided by square root of 1 plus 1 is 2. So I'm showing you that conjugate technique when you're dealing with square roots. Okay, so I'd like to end this first tutorial with a couple tries, and I sort of lied to you. I guess you need to get the calculator out. There are two limits that I'd like for you to use your calculator table and review that technique to go and find. So if you could please pause the video and do those two, and then try 3. You're not using a calculator. You're doing it by the method that you just learned in this tutorial. Why don't you pause this, spend a couple minutes, and then come back and check your answers. So thanks for doing these try problems. These first two are going to occur many times in calculus, which is why we'd like you to start memorizing them now. The limit as x approaches 0 of the sine of x divided by x will always be equal to 1, and I always see that sort of right in the sine of x symbol. I see the 1 right there. That's how I remember that one. The limit as x approaches 0 of 1 minus cosine of x over x will always be equal to 0, and I sort of see the 0 right here in the symbol for cosine of x. So that's how I remember those two things. So please memorize those. Try 3, you had to go find the the common factor, which was x minus 5. Cancel it away. You have your limit symbol on each of these steps, and then you introduce your equal sign when you're able to evaluate, and of course 5 plus 2 equals 7. Thanks for watching this tutorial, and we'll practice these techniques. I've got one more problem in the next tutorial for you. Ah, thanks. I'll see you in class.